first. Hold on. It didn't register my answer. 'Cause I was doing something. To multiply a number by 12, multiply it by 10, and then add 2 more 5s to it. In other words, 10 times 5 is 50. What's 2 times 5?
60.
So 60 must be the answer. Yeah, it's 2 times 5 is 10, and we're adding 10 to 50. So 60, is it plus or minus?
It's plus.
All right. What's this one? And then we'll go on.
That would be 13.
Okay, good. Cool. Let's see here. Factoring. Did you have some information you wanted to give me about your test? What?
I don't really know what to tell you about it.
What do you know about it? What kind of stuff do you know to be on it? Have they given you any review material?
No. So, well, I already took the test.
When did you take it?
I think it was 2 days ago. Yeah.
Oh, well, how'd you do on it?
I don't know.
Oh, you don't have the result back yet? Well, what kind of stuff was it? Was it algebra? Was it arithmetic? Was it fractions?
All around, like with fractions, variables, plus and minus, subtraction.
So everything we've been working on.
Yeah, basically, yeah.
Okay. Yeah. If there was something on it that we haven't been working on, then try to remember it and let's work on that. Did you have any factoring?
I had like one problem.
Okay, like greatest common factor or factoring into 2 parentheses kind of stuff?
Like in 2 parentheses.
Okay, good. Let's pick back up on that. Let me give you a simple one. Excuse me, this is supposed to be a 6. Step 1.
Step 1. You would divide each side by, that wouldn't work.
What's step 1? That's why I think it's important to remember them as steps 1, 2, and 3. Because step 1 is always the same. Split up your x squared.
X and X.
There you go.
There.
On elementary quadratics, that's always going to be step 1. As we get more complicated, then that might be sometimes 2x and x, or 2x and 2x. So it can get more complicated, but we're going to stick with these level problems until you master that. What's step 2?
Then it would be minus and a minus.
Good.
And then it would be 3 and 2.
What are factors of 5? You just gave me 2 numbers that add to 5. We need numbers that multiply to 5.
But they're like, does fractions count?
No. Let's list the factors of 5. Well, always 5 and 1. In other words, a number and 1 are always going to be factors. Are there any other factors of 5?
No.
There aren't. But that satisfies our condition. What's step 3?
So 5 and 1.
Right. Factors of 5 that add to the number 6. It doesn't matter which one goes where. All right. Change it slightly. going to work with negative signs now. These are just slightly harder, but just slightly. Step 1.
The 2 x's.
Step 2.
And plus and minus.
Step 3. Verbalize it for me.
It would be 5 times 5, and it wouldn't matter. No, because that would be...
What's factors of 10? First of all, you got to be able to figure out factors of 10.
So, it would...
Remember, it's not two numbers that add to 10. It's two numbers that multiply to
10 and 1.
Okay.
5 and 2.
Okay, and what are we looking for? Factors of 10 that do what?
Multiply to 3.
That subtract to 3. So all the inside stuff is adding and subtracting. To get this number, we need numbers that are multiplied. And finally, so I found my two numbers. 5 and 2 subtract to 3. How do I know where to put the 5 and how do I know where to put the 2?
I forgot that.
You put the bigger factor with the sign of the middle. So every time we do one of these two signs are very important. They answer steps 2 and 3 and 4 in this case. So the 5, the middle sign is a negative, so the 5 goes with the negative. We just barely covered negatives when we ended last time, so we haven't really done much with these. And now, how do I know if I've done it correctly?
You add you minus the 2 and see if it equals 3.
Well, I could multiply x plus 2 times x minus 5. I could just go through that multiplication and see if I get the same quadratic. But a lot of that work is unnecessary. You really only need to do 2 steps of the FOIL. I'm beginning to realize why they do teach a FOIL, because it is actually a little helpful to learn FOIL as opposed to ET. Because you quickly realize that you get this term by multiplying the insides and the outsides, and then adding those two numbers. Well, when I multiply the insides, I get a 2x. When I multiply the outsides, I get a minus 5x. When I add those two together, I get minus 3x. That is my middle term. I did it correctly. I don't need to check anything else. So I don't really need to fully multiply these back together again, at least not in my book. Now, it may be when you take a class that they'll say, okay, after you've factored it, multiply this back together again fully to make sure you start, that you get with what you started. Okay?
Okay.
Step 1.
X and X.
Step 2.
Plus minus.
And step 3, verbalize it.
So 1 and 12, 4 and 3, and wait, but there's not a number there.
Hold on. Let's go through factoring again, because I have a certain way I like to do it. The next step I'm going to do is cut this one in half, because I know I can double that. So, okay, like that. And then I can do the same thing. I can again cut 6 in half and double 2. Now I can no longer do that. I can't cut 3 in half anymore. I could cut 4 in half, but that just gives me what I had. So I'm pretty sure I got all the factors here. Now, verbalize Rule 3. Tell me how it...
Well, we don't know that number before the x.
Well, hold on. By verbalizing Rule 3, I mean our next step is to find factors of 12 that do what to what?
That equal the number before it.
Factors of 12 that they're going to either add or subtract. What is it in this case?
Subtract.
Okay, so factors of 12 that subtract because of that. To what number?
I don't know.
The coefficient of the middle term. What is the coefficient of this middle term? 1. Yes. It's not x, it's 1. So our goal for step 3 is to find factors of 12 that subtract to the number 1. So which set of factors is that? 3
and 4.
Okay. Where's the 4 go? Where's the 3 go?
The 4 goes on the second and the 3 goes on the first.
Okay. Notice that when I check, there's plus 3x. Check that. That's minus 4x. Perfect. Minus 1x. Or minus x. This is a good problem because that's a very, very common mistake that people make, is when there's no coefficient, when it's an implied 1, they don't want to see that 1. In other words, had the problem been that, it would have been a piece of cake, or let's say that. In other words, if it was a minus 4 there, then you would have known that it was factors of 12 that subtract to 4. But when it's not written, it's harder to see. All right. One last kind of extremely important factoring that I want to get to today. So far, we've talked about greatest common factor, right? That's when you basically just divide an expression by one thing. And it's pretty easy to come up with that. In other words, if I had x cubed, let's say I had 2x cubed plus 4x, what's the greatest common factor?
It'd be like 2.
Well, 2 what?
2x.
2x, there you go. What's left over?
1. Wait.
Yep, keep going.
1x.
What's x cubed divided by x? Subtract the exponents.
3x.
No, this has an exponent of 1. Again, an invisible 1. So when I divide x cubed by x to the 1, I'm going to get x squared. Okay, and then what's the second term?
1.
What's 4x divided by 2x?
It'd just be 2.
Just like that. Okay, so greatest common factor is the easiest way to factor. That's without a doubt. There's nothing easier than that. When we step up to the level, or to the next level that we've been working on, where you're factoring a standard quadratic expression like this, where you have a constant. In other words, the moment you get beyond being able to take out a greatest common factor, you're at this second type. And finally, there's a third type that's called difference of perfect squares, which sounds complicated, but when you think about it, it's really quite easy. There's a perfect square. There's a perfect square. We're taking the difference of them. That's always factors into that times this. Okay. For example, if I had x squared minus 4, then a squared is x squared, so it must be x is a, right?
Mm-hmm.
So what would that factor into?
That would factor into x squared.
No, just x. Remember, this is just a.
Minus
2 times, and the second part's always just the conjugate. Conjugate. In other words, it's the same thing as the first part, opposite sign. Now, do you see why this is 2 and not 4? In other words, we're really taking the square root of b squared, which is b. So if b squared is 4, then b must be 2. With me?
yeah.
Factor this.
What's half of 25?
It's not half. Square root of. Square root of. What two numbers that are the same?
5.
Okay.
So minus 5, and then x plus 5.
That's it. So difference of squares is almost easier than greatest common factor. Is all you have to do is take the square root of each side. Let me give you a little harder one. So whatever goes there is the square root of that. And whatever goes there is the square root of that.
So would it be 2x minus 6, and then the reverse of that?
Very good. Okay, here's one that most people don't usually get because they don't realize that 1 is a perfect square number. In other words, this only works with perfect square numbers. If I do a 2 there, then I'm not going to factor like that. Okay? So the number that is here has to be a perfect square number or it doesn't work. But 1 is a perfect square number. 1 times 1 is equal to 1. So
x minus 1 and x plus 1.
that's it. Cool. I'm saying cool because we've covered all the factoring you're going to need to know for a while. Let's do another one. Now, you may not actually see anything this hard, but you should be able to figure this one out.
So it'd be 4x squared minus 3, and then 4x squared plus 3.
You got it. That's all there is to difference of perfect squares. And it can include variables also. It doesn't always have to be. In other words, if I had that, what is it?
It'd be 4x squared minus 3y, and then the reverse of that.
Good. I think you got that. Good. Very good. All right. I'm thinking here because we have covered everything that you've indicated you took on that test. I mean, not that, we can still practice it and go back over it. I'm trying to think if there might be anything else that, oh yeah, inequalities. have you had to deal with anything that looks like this?
Well, I don't know. That wasn't on our test.
Was it? It wasn't. So you have not had inequalities, okay. About
Skill to learn.
What's that?
I think it would be a good skill to learn.
Oh yeah, you'll get it for sure. It's coming up. It's just that I kind of want to, and I don't mind going there. We can certainly go there. In fact, let's talk about it because it's not that tough. In other words, you basically solve an inequality in the same way that you solve an equation for the most part, except in one situation. But the way you solve an inequality is kind of treat it as an equation, subtract 3 from both sides, and I get x has to be greater than 7. And that's my answer. Okay, easy enough. However, if there is ever a need to multiply or divide both sides of the inequality by a negative number, then you have to reverse the direction of the inequality. In other words, my first step is still to move the 3 over. So I have minus x is greater than 7. But now I have to divide both sides by minus 1 in order to get rid of that minus sign that's in front of the x. Okay, well, that leaves me with x over here. But because I divided by a negative number, I got to turn that inequality the other way. And on the right side, I still have minus 7. So that's how you solve an inequality if you have to divide or multiply either side or both sides by a negative number. That's the only difference. Every other situation, you solve it exactly the same way as you do an equation. All right. That's probably a good place to stop. When are you taking your test again?
I don't think we're taking our test again.
You don't have to take that one again? So the test you took 2 days ago, that was to place you in the math class that you're going to go into? And that's it. You're done with that, huh?
Yeah, I think so.
Okay. That's okay. Well, we can still help you out a lot by getting you very prepared for that class. And I think we're doing that. We've actually covered quite a bit of stuff. And you're doing good on the A+. The only thing you might try with the A+ math, Garrett, is turning the timer on and start paying attention to time. The faster you can get and still be accurate, the better off you're going to be, by a lot. In other words, if it takes you a certain speed to do it, you're going to almost find that it's faster to do on a calculator, and eventually you're going to go back and use the calculator to do all those. And you don't want that to happen. That's a big mistake. You want to keep your arithmetic skills fresh enough that you can always do single digit by single digit in your head without a calculator, and quickly and accurately. So that's the goal. So keep on practicing.
Okay.
All right, Garrett. Talk to you next time.